Minute Math. When you need help, you use Minute Math.
Hi, I'm Sean Gannon, and this is Minute Math. And today we're going to learn about radical equations. And we're going to solve each equation. Remember to check for extraneous solutions. So, if I was given this equation, square root of x equals 10. Well, to get rid of that square root, I want to isolate x. What I need to do is square both sides. Square both sides of the equation. Okay? By squaring both sides of the equation, we're left with just an x here, right? And then 10 squared being 100. So we have an answer of x equals 100. Well, I need to see if that actually works. I'm going to check with playing it back and to see if it becomes a true statement. So I take my original statement, the square root of x in that case equals 10. Want to put that x in 100, right? From the original equation. 100, square root of 100 is 10, and 10 does in fact equal 10, and so we've checked it. 10 equals the square root of m over 10. Well, first thing I need to get rid of is the square root. I'm going to square both sides. So by squaring both sides here, it eliminates the square root on the right, leaving with m over 10 here. On the left, I have 10 squared, which is 100. I then see m divided by 10, get rid of that. Opposite of division is multiplication. I multiply both sides by 10, leaving me with 1,000 equals just m. Okay, so I have m equals 1,000, and we can write it nice and neat and write m first. M equals 1,000. Well, now I need to check that, right? So to check that, I'm going to take my original equation, 10 equals the square root of m over 10, and I'm going to plug 1,000 into it. So I have 10, this is my check, 10 equals the square root of 1,000 all over 10. Okay? 1,000 divided by 10 is 100, so I have 10 equals the square root of 100. And the square root of 100 is 10. And there we go. We checked, we saw that it was right, so we don't have an extraneous solution. So our final answer is m equals 1,000. Square root of v minus 4 equals 3. My first step is to square both sides. So I'm going to square both sides, and that eliminates my square root. By doing so, I'm left with v minus 4 on the left and 3 squared on the right, which is 9. And then I have to add a 4 to both sides, leaving me with v equals, well, what's 4 plus 9, or 9 plus 4, which is 13. So I have v equals 13. Well, now I need to check that. Check to see if that's a true answer. So I go back to my original equation, the square root of, and instead of a v, I'm going to put a 13 in there. 13 minus 4 equals 3 on my original equation. So from there, 13 minus 4 is 9 equals 3. The square root of 9 is 3, right? So I'm going to leave whatever is the equal to on the right, keep everything on each side with the equal sign, and simplify and see if they're equal, and they are. 3 does equal 3, therefore making v equals 13 my real answer. Okay, there was no extraneous solutions. Equation 6 equals the square root of b minus 2. So 6 equals the square root of b minus 2. My first step, I need to square both sides. Get rid of that square root. Leave me with 6 squared is 36 equals whatever b minus 2 is, right? Well, b minus 2 is easy. I bring a 2 over, add a 2, and I'm left with 38 equals v. And then I can just write it nice and neat, put v first, so v equals 38. But now I need a check. Okay? So to check here, I write my original equation, 6 equals the square root of v minus 2. And then I'm going to plug in a 38 in for v. So 6 equals the square root, 38 minus 2. So now I'm going to solve this, right, or simplify really, and keep everything on each side of its own, on each side of the equal sign, right? So 6 stays by itself here, and I'm going to simplify on this side, and hopefully we get a 6. 38 minus 2 is 36. Square root of 36 is just 6. And there we go. 6 did equal 6, so we're good. And so our answer of v equals 38 was correct. Of n equals 9. Well, my first step is to eliminate the square root by squaring both sides. So to do that, I square both sides here, leaving me with just an n on the left, which eliminates that square root, equals 9 squared, which is 81. So that's it. N equals 81. So now I need to check. So to check here, I'm going to take my original equation, square root of n equals 9, plug 81 in for n, substitute that in, and then simplify. So square root of 81 is just 9. And 9 does equal 9. That's true. The right and left side both equal, so we're good. So n equals 81 is my final answer. It's a correct answer. There is no extraneous solutions. 5 equals the square root of x plus 3. Okay, that's it. I know I made it sound like I was having something else there. So the first thing to eliminate the square root is I need to square both sides. So I'm going to square both sides here. I really should leave myself more room. Square both sides, leave me with the left-hand side 25 equals x plus 3, because remember, squaring a square root eliminates the square root. I then subtract a 3 to both sides, leaving me with a 22 is equal to x here, okay? And then I can write it nice and neat. X comes first, so x equals 22. Well, now I need to check. Okay, I need to check that. So to do that, I rewrite my equation. 5 equals square root of x plus 3. Now I square both sides. I'm sorry, I'm not solving here. I'm checking. I take 22 and plug it in for x. So 5 equals 22. The square root of 22 plus 3. Let's simplify this. 22 plus 3 inside the square root is a 25. 5 is on the outside. Square root of 25 is just 5. They're equal. We're good. That means 22 was my answer, my real solution here. 2 equals the square root of 4b. Well, to eliminate the square root, I need to square both sides. In doing so, 2 squared is 4, and then eliminates here the square root 4 times b. 4b, 4 times b. To get b by itself, I have to divide by 4 to both sides. Leaving me 4 divided by 4 is 1, equals b. I can rewrite this, make it nice and neat, as b equals 1. Okay? But now I need to check. So doing so, I write my original equation, 2 equals the square root of 4 times b. And then I'm going to plug this 1 in for b. So we have 2 equals 4 times 1. All right, now we're going to simplify. 4 times 1 is just 4. Square root of 4 here. Square root of 4 is 2. And there we go. 2 equals 2. My left and right side are equal, so we're good. So b equals 1 is my real answer. There's no extraneous solution. Of n plus 9 equals 1. So my first step is to eliminate that square root. I'm going to square both sides here. And in doing so, I eliminate the square root on the left, leaving me with n plus 9 here, equals 1 squared, which is just 1, which is fantastic. Okay? I then need to subtract a 9 to both sides, leaving me with n equals 1 minus 9, which is negative 8. So now I need to check to see if that's a real solution or extraneous solution, right? And so I'm going to rewrite my equation. Well, I'm going to check it here. So rewrite my equation, square root of n plus 9 equals 1. Plug negative 8 in for n, so square root of negative 8 plus 9 equals 1. Simplify, negative 8 plus 9 is 1. Square root of 1 equals 1. Square root of 1 is just 1, so 1 does equal 1, and we're good. That's true, right? Fantastic. So n equals negative 8 is a true answer. Negative 8 plus the square root of 5a minus 5 equals a negative 3. So I want to get a by itself. So my first step is actually adding an 8 to both sides here. Okay, I can only square both sides with square root if it's isolated. So I'm left with the square root of 5a minus 5 inside of square root equals negative 3 plus 8, which is 5. I then square both sides of the equation, leaving me with 5a minus 5 on the left equals 5 squared, which is 25. A lot of 5's here. I then add a 5 to both sides, leaving me with 5a equals 30. I then divide by 5 to get a by itself, and a equals 6. Okay? So now I need to check to see if that's a true answer. So I'm going to rewrite my equation. Negative 8 plus the square root of 5a minus 5 inside the square root here equals negative 3. I'm going to plug 6 in now, so I have negative 8 plus square root of 5 times 6 minus 5 equals negative 3. Well, 5 times 6 is 30, so negative 8 plus square root of 30 minus 5 equals negative 3. 30 minus 5 is 25. So 25 in the square root. The square root of 25 is 5, so negative 8 plus 5 equals negative 3. And negative 8 plus 5 does in fact equal negative 3. So my left and right are equal. Fantastic. A equals 6 is my real answer here. Nothing was extraneous. 10 times the square root of 9x, and that was equal to 60. Well, my first step is to get the square root by itself. So I'm going to divide by 10 to both sides. Because remember, there's really a multiplication going on there. That eliminates a 10, leaving me with the square root of 9x here on the left equals 60 divided by 10, which is just 6. I then need to eliminate the square root, so I'm going to multiply or square both sides here. Square both sides. So we're left with 9x equals 36. Well, I have 9 times x. Divide 9 to both sides, leaving me with x equals, well, what's 36 divided by 9, which is 4, right? So x equals 4 here. So now I need to check that. Check. So I'm going to rewrite my equation. 10 times the square root of 9x equals 60. And let's go plug 4 in for x. So we have 10 equals square root of 9 times 4 equals 60. Well, 9 times 4 is 36. So 10 times the square root of 36 equals 60. Then square root of 36 is 6, so I have 10 times 6 equals 60. 10 times 6 is 60. So my left and right are equal. Fantastic. X equals 4 is my final answer now. It's confirmed. 1 equals the square root of x minus 5. Well, I see there's a square root. I need to eliminate it. It's isolated. Fantastic. So I'm going to square both sides. 1 squared, well, I could mess up this one. 1 squared is just 1 equals, well, square root eliminates. We're left with x minus 5 here. Add a 5 to both sides. Giving me 1 plus 5 is 6 equals x. Rearrange this so it's nice and neat. So x comes first. X equals 6. So now I need to check that. So to check it, I rewrite my equation. 1 equals the square root of x minus 5. And now I want to plug 6 in. So I have 1 equals the square root of 6 minus 5. 6 minus 5 is just 1. Right? Square root of 1 is just 1. So I have 1 equals 1. Left and right hand side are equal. Fantastic. So x equals 6 is my final answer. Negative 10 times the square root of b minus 10 equals negative 60. Okay? Well, first step is I need to divide by a negative 10 to both sides. That eliminates this. Remember, there's multiplication going on between negative 10 and the square root. So now I have the square root of v minus 10 equals negative 60 divided by negative 10 is a positive 6. I then have to square both sides because the square root is isolated, so I need to get rid of it. Right, since it's isolated, I can do this. So I'm left with v minus 10, not equals 10. V minus 10 equals 6 squared, which is 36. I then add a 10 to both sides, leaving me with v equals a 46. So now I need to check that. So negative 10, I rewrite my equation, square root of v minus 10 equals negative 60. I then plug 46 in for v, so I have negative 10 times the square root of 46 minus 10 equals a negative 60. 46 minus 10 is 36 equals negative 60. Square root of 36 is just 6, so I have negative 10 times 6 here equals negative 60. And negative 10 times 6 is negative 60. Fantastic, left and right are equal, and so v equals 46 is my final answer. It's not extraneous. 10 plus the square root of 10m minus 1 equals 13. Okay? Well, we first need to isolate the radical, right? Square root. So I'm going to subtract the 10 to both sides. In doing so, I'm left with the square root of 10m minus 1 here equals 13 minus 10, which is 3. From there, I need to get rid of the square root, so I'm going to square both sides, leaving me with just what's inside the square root of 10m minus 1 equals 3 squared, which is 9. And I'm going to add a 1 to both sides, leaving me with 10m equals 10, right? 9 plus 1 is 10. Then I divide by 10, giving me my final answer, which I'll write here is m equals 10 divided by 10, which is 1. Well, we need to check to see if that's a correct answer. So I'm going to do my check over here. Check. So I'm going to rewrite my equation. 10 plus square root of 10m minus 1 equals 13. Then I'm going to plug 1 in for m. So I have 10 plus 10 times 1 minus 1 equals 13. Well, I'm going to simplify this. 10 times 1 is 10. So we have 10 plus square root of 10 minus 1 equals 13. 10 minus 1 is 9. So we have square root of 9 in there. Square root of 9 is 3. And 10 plus 3 is 13. And they're equal, right? On both sides, 13 is equal to 13. Check. And so therefore we can be confident that m equals 1 is our solution. Negative 12 equals negative 6 square root of b plus 4. All right. So now I want to simplify this. To do that, I need to get a radical by itself. So I need to divide both sides by negative 6. Negative 12 divided by negative 6 is a positive 2. Right? Negative divided by negative is a positive. And then I'm left with the square root of b plus 4. To eliminate that square root, I need to square both sides of the equation. 2 squared comes out to be 4, and I'm left with b plus 4 on the right. Subtract a 4 to both sides to get b by itself. 4 minus 4 is 0. And so my final answer here is b equals 0. I'm going to rewrite it first with the letter b first. So it's b equals 0. So now I need to check. I'm going to check this. So I rewrite the equation, negative 12 minus 6 times the square root of b plus 4. And I'm going to plug 0 in for the variable b. Minus 12 equals negative 6, square root of 0 plus 4. Well, 0 plus 4 is just 4, right? So we have negative 12 equals negative 6, square root of 4. Square root of 4 is 2, so negative 12 equals negative 6 times 2. Negative 6 times 2 is negative 12. My left and right hand side are equal, confirming that b equals 0 is my true final answer. There are no extraneous solutions. The square root of b plus 3 minus 1 equals 7. Well, my first step is I want to bring a 1 to the right. I'm going to add a 1 to both sides. Leave me with the square root left over to the left, b plus 3, equals 7 plus 1, which is 8. Okay. From there, I have to eliminate the square root, so I'm going to square both sides. That's the opposite operation of square root. Square root squared leaves me with just the b plus 3 left on the left, and 8 squared is 64 on the right. I then subtract the 3 to both sides to get v by itself. I'm left with v equals 64 minus 3, which is 61. So now I need to check. Don't forget that step. You need to check this. So the square root of v plus 3 minus 1 equals 7. Be careful. The square root goes over to the 3, but not the minus 1. Attention to detail here. Now I'm going to substitute 61 in for v. So 61 plus 3 minus 1 equals 7. Be careful again, that square root is just over the 61 plus 3. 61 plus 3 is 64. Minus 1 equals 7. Square root of 64 is 8, right? Minus 1 equals 7. 8 minus 1 is 7. Left and right hand side are equal. Fantastic, that's great. So we're confident that v equals 61 is my final answer. 90 equals 9 times, or 9 square root. We just know there's going to be a multiplication there. 25 times the letter v. Okay, so now I want to simplify this. Okay, so there's multiplication, like I said right there, right? Multiplication there. So opposite of that is division. Divide by 9 on both sides. 90 divided by 9 is 10. 9's cancel, leaving with the square root of 25v on the right. I need to square both sides to eliminate that square root, right? Kind of makes sense, doesn't it? 25v is left on the right, but 10 squared is 100 on the left. Divide both sides by 25 because there's multiplication going on here. And now we're left with 100 divided by 25 is 4 is equal to v. Now we want to write v first because that looks nicer, so v equals 4. So far, I believe that is my answer. But I need to check my work, so I need to check right here. This is an important step. Don't skip it. Don't be lazy. 90 equals 9 square root of 25b. Okay, simplify. So I'm going to divide, oh my goodness, I'm not solving. I'm checking. Got ahead of myself. I'm going to plug 4 in for v. So I have 90 here equals 9 times the square root of 25 times 4. 25 times 4 is 100, so we have 90 equals 9 times square root of 100. Square root of 100 is 10. 90 equals 9 times 10. 9 times 10 is 90. And left and right are equal. Check. It works, so v equals 4 is my final answer. 3n equals, double square roots here, square root of 4n minus 1. Well, I have a square root on both sides, but both of them are isolated, which is nice. So I'm going to square both sides. By squaring both sides in one step, I eliminate both of the square roots. Leaving with 3n on the left and 4n minus 1 on the right. Now it becomes a very simple problem to solve. I'm going to subtract a 4n to both sides, leaving me with 3 minus 4n, which is a negative n, equals a negative 1. Well, if I divide by negative 1 to both sides, that leaves me now with n equals, well, negative 1 divided by negative 1 is a positive 1, because remember, negative n divided by negative 1 is a positive n. So now I'm done. N equals 1. Fantastic. So a problem that had 2 square roots in the beginning, right? First looked hard, but it actually was a fairly simple problem. But we still need to check for extraneous solutions. So I'm going to check right here. I'm going to rewrite my equation, 3n, don't need that big of a square root, equals square root of 4n minus 1. Now remember, I'm going to plug this 1 in for both n's here. So the square root of 3 times 1 equals the square root of 4 times 1 minus 1. Okay? Remember your order of operations, 3 times 1 is 3. 4 times 1 is 4. We have the minus 1 still underneath the square root. Square root of 3 I'm not going to change right now. 4 minus 1 is 3. They are equal, right? Square root of 3 is equal to 3. That's a true statement. Left and right are equal. I don't need to write what the decimal is or anything like that. I see that they're exactly equal. I can consider that a good enough check for me. So they're both the same, confirming that n equals 1 is a true answer. The square root of 2n minus 88 equals the square root of n over 6. Okay? Well, first step, both square roots are already isolated, so I can just square both sides. Let's eliminate both of these radicals, leaving me with a 2n minus 88 on the left and n over 6 on the right. Now this one's tricky, okay? This one becomes a little tricky because how do we get the 6 over there? What can we do? There's a few things we can't do, okay? And this is what I'm going to suggest. I'm going to multiply by 6 to both sides. But be careful, we have 2n here, right? So I have to multiply it to everything. So I'm going to put the 6 over there outside. I've kind of created these new parentheses, put the 6 over there. So now these 6's will eliminate, okay? But leaving me with 6 times 2n minus 88. 6 times 2n is 12n, right? I'm going to distribute, fantastic. Minus 6 times 88. What's that? Well, we got to solve that, right? So I'm going to do it right here, right? 88 times 6, okay? Well, 8 times 6 is 48. 8 carried the 4. 8 times 6 is 48 plus 4 is 52. So we have 528 here equals n, okay? So that's tricky here, but we're going to take our time here. And so from there, I need to simplify. So there's a few ways you can go about it. So I'm going to, well, let's go add a 528 to both sides. Right, there's nothing there, and we'll subtract the n to both sides, leaving me with 11 n on the left equals 528 on the right. Okay? So now I have to divide by 11. Okay? So divide by 11 on both sides, giving me n equals whatever 11 and 528 is. 11 goes into 528. 11 goes into 44 4 times. 44 is less than 52, so we're good. 44. Subtract them. 52 minus 44 is 8. Bring down the 8. 11 goes into 88 8 times. 8 times 11 is 88. 0, fantastic. So n equals 48 is my final answer. But now I need to check. Okay, so I'm going to check this. So I'm going to rewrite my equations. 2n minus 88, try to keep my space here, equals the square root of n over 6. Well, let's go plug in 48 in for n here. So square root of 2 times 48 minus 88 equals square root of 48 over 6. Okay? Well, let's see. 2 times 48, what does that come out to be? 2 times 48 is 96, right? 96 minus 88 equals the square root was 48 divided by 6 is 8. 96 minus 88 is 8. Square root of 8 does equal square root of 8. Oh, check, we're good, right? So fantastic. So n equals 48 is my true answer. X over 10 equals the square root of 3x minus 58. Well, first thing, I want to square both sides. The square roots are already by themselves, all right? They're isolated, so squaring both sides will help me eliminate those square roots, leaving me with just an x over 10 on the left and 3x minus 58 on the right, okay? Well, from there, I'm going to multiply by 10 to both sides, right, to get x by itself here on the left, all right? So I actually have to multiply by 10 both sides, but what that does, remember, goes to both parts here. 10's cancel, leaving me with x equals 10, distribute 10 times 3x is 30x, and 10 times 58 is 580. So now let's get all the x's together. So I'm going to subtract a 30x to both sides. Right there. X minus 30x is negative 29. X equals a negative 580. Okay? So now we want to see how many times does 29 go into 580. Now, I divide both sides by negative 29. 29, not 8. So let's do long division here. 29 goes into 580. Okay? 29 goes into 580. Well, 29 goes into 58. That's going to be twice, right? 58, right? 2 times 29 is 58. Subtract them. 58 minus 58 is 0. Bring down the 0. 29 goes into 0. 0 times 0 times 29 is 0. Really doesn't matter. 0. 20. And so x equals positive 20 is my solution here. But I still have to check it, right? Check it. So to do that, I'm rewriting my equations. So I'm going to write the square root of x over 10 equals the square root of 3x minus 58. Now I'm plugging 20 in for both x's. So I have square root of 20 over 10 equals the square root of 3 times 20 minus 58. Okay? Well, 20 divided by 10 is just 2. So we have square root of 2 here. And 3 times 20 is 60 minus 58. Remember, the square root goes over both parts right there. 60 minus 58 is just 2. So we have square root of 2 on the right and square root of 2 on the left. Left and right are both equal, confirming x equals 20 is my answer. 3n plus 12 equals the square root of n plus 8. Well, I have a square root on both sides, and to eliminate them, I have to square both sides. Both of them are already isolated, so we're fine. We can do that. So we square both sides here. Square roots get eliminated. We're left with 3n plus 12 equals n plus 8. Okay. Now I'm going to solve for n. I'm going to subtract an n to both sides here, and I'm going to subtract a 12 to both sides. I'm going to do both in one step. 3n minus n is 2n. And then when I subtract 12s here, 8 minus 12 is negative 4. Okay? Leaving me then with 2n equals negative 4. I'm going to divide both sides by 2, leaving me with n equals negative 4 divided by 2, which is negative 2. And so right now, so far, I'm pretty sure that's my answer, right? So now I need to check my work. I'm going to check it right here. So I'm going to rewrite my equation, 3n plus 12 equals the square root of n plus 8. Okay, square root, square root. So now I'm going to plug in negative 2 in for both ends. So we have square root of 3 times negative 2 plus 12 equals square root of negative 2 plus 8. Well, 3 times negative 2 is negative 6. And negative 2 plus 8 is a positive 6. Okay? Negative 6 plus 12 is a positive 6. So we're left with a positive 6 equals a positive 6. Fantastic. Left and right are equal, confirming that n equals 2 is my final answer, and we don't have an extraneous solution. Square root of n equals the square root of 2n minus 6. Well, the square roots are on both sides of the equation, and they're already isolated, so all I have to do is square both sides, and that will eliminate the square roots. Square root squared is just, gets eliminated, we're left with just n, equals on the right-hand side 2n minus 6. Well, I'm going to subtract the 2n to both sides, get the n's together. N minus 2n is negative n equals negative 6. And then I'm going to divide by negative 1, essentially just bring the negative over, leaving me with n equals negative 6 divided by negative 1 is a positive 6. So we have n equals positive 6 here. Fantastic, but we need a check. So let's do our check. So by checking, I'm going to rewrite my equation. Square root of n equals the square root of 2n minus 6. And now I'm going to plug 6 in for n. Square root of 6 here on the left, which is fantastic. 2 times 6 minus 6. 2 times 6 is 12. So we have 12 minus 6 here. Then 12 minus 6 is just a positive 6. Excuse me, my left and right equations are equal. Fantastic. Check. We are good. Let's make a better check. Yeah, big old check. Okay. Good. Confirming we have no extraneous solutions, and n equals 6 is my true and final answer. Square root of 11 minus x equals the square root of x minus 7. Okay? Well, square roots on both sides. I'm going to square both sides, eliminate them right here. Get rid of them. We're done. Square roots are gone. 11 minus x is here on the left, and x minus 7 on the right. So now we combine our like terms. So I'm going to add an x to both sides, bring my x's to the right and my numbers to the left. 11 plus 7 is 18. X plus x is 2x. Okay? Divide both sides by 2. Get x by itself. 18 divided by 2 is 9. 9 equals x. Let's rewrite it. X first looks nicer. X equals a positive 9. But now I need a check. I'm going to check that bad boy. So I'm going to check it. Rewrite my equation. 11 minus x equals the square root here of x minus 7. The other one has square root as well. I'm going to plug in 9 for my x's. So 11 minus 9 here, underneath the square root, and then 9 minus 7. Simplify. 11 minus 9 is 2, so a square root of 2 here equals 9 minus 7 is also 2. So a square root of 2 is square root of 2. Check off. They are the same. Fantastic. So I can confirm that we have no extraneous solutions, and that x equals 9 is my answer. Square root of 72 minus x equals square root of x over 5. Well, to eliminate the square roots from both sides, I'm squaring both sides, leaving me with a 72 minus x on the left and x over 5 on the right. But now I need to put the 5, get rid of that 5. So I'm going to multiply both sides by 5. Be careful with the left-hand side. Put your parentheses, because it has to go to both parts. Let's distribute. 5 times 72. Don't know off the top of my head. So 72 times 5. 2 times 5 is 10. 0 carry the 1. 5 times 7 is 35. Plus 1 is 36. So we have 360 here. 360 minus 5 times x, which is 5x, equals, these eliminate just x. Now I'm going to add a 5x to both sides. Leave me with a 360 on the left and 6x on the right. Divide both sides by 6, okay? And that comes out to be, well, it's 360 divided by 6 is really just 60, okay? 60 there. Yeah, 6 goes on 366 times. Hopefully you know that. If not, no worries. You can do long division. So we have 60 equals x here. Rewrite that. Nice and neat. X equals 60. X coming first. So let's check. We have the square root of 72 minus x equals the square root of x over 5. Plug 60 in for x. 72 minus 60 equals 60 over 5. 72 minus 60 is 12. Square root of 12 there. And 60 divided by 5 is also 12. Leaving me with 12 equaling 12. Fantastic. That's correct answer there. And so we have no extraneous solutions, and x equals 60 is my final answer. The square root of x plus 3 equals the square root of 1 minus x. First step, I need to square both sides. Eliminates the square root, giving me with the x plus 3 on the left and 1 minus x on the right. Well, now I'm just adding my like terms. I'm going to add an x to both sides here, and I'm going to subtract a 3 to both sides. These 3's cancel, these x's cancel, leaving me with 2x, which is x plus x, equals 1 minus 3 is negative 2. Divide both sides by 2. Oh, positive 2 to both sides, not negative 2. So I'm left with x equals negative 2 divided by 2 is a negative 1. So we need to check to see if that's a correct answer, right? So let's check. And also check for that extraneous solution, really. So we have square root of x plus 3. I'm rewriting the equation. Square root of 1 minus x. Let's plug negative 1 in for x. So we have square root of negative 1 plus 3 equals square root of 1 minus, now I'm putting that negative 1 in. Negative 1 plus 3 is negative 2. Positive 2, oh my goodness, positive 2. Oh, am I going to have myself here? Negative 1 plus 3 is a positive 2. And then 1 minus a negative 1 is 1 plus a positive 1, right? And it's a square root of 2 there. Left and right are equal. Fantastic, right? So that confirms we have no extraneous solutions, and that x equals negative 1 is my final answer. Square root of 2k plus 40 equals the square root of negative 16 minus 2k. Well, I'm going to square both sides. Both radicals are isolated, so I can square both sides to eliminate them. And it's a 2 for 1 special here, deleted. So we have 2k plus 40 equals a negative 16 minus 2k. So let's bring our k's together and our numbers together. So I'm going to add a 2k to both sides. I always want to say toucan, but it's 2k. And I subtracted 40 both sides. Leaving me with 2k plus 2k is 4k. These 40s cancel. These 2k's are canceled. And negative 16 minus 40 is a negative, ready, 56. Okay, negative 56 here. So now I need to divide both sides by 4. And we're left with, well, what's negative 56 divided by 4, which is a negative 14. Okay, negative 14 there. And so we have k equals a negative 14. But I need to check. So I'm going to check it by rewriting my equation. So square root of 2k plus 40 equals the square root of negative 16 minus 2k. I'm going to plug negative 14 in for both k's there. So I have 2 times negative 14 plus 40 equals negative 16 minus 2 times negative 14. Careful with our negatives. 2 times negative 14 is a negative 28. So square root of negative 28 plus 40 equals, here on the right, negative 16 minus 2 times negative 14 is a negative 28. Okay, negative 28. Now be careful. Subtracting negative, same thing as adding a positive, so that's like plus a positive 28. That's a weird looking, it looks more like a snowman, to be honest. So we have a positive 28 there. And so negative 28 plus 40 is a positive 12. And on the right-hand side, negative 16 plus 28 is also a positive 12. Left and right are equal, which is fantastic. And so it means we don't have extraneous solution, and it confirms that k equals negative 14 is my final answer. Square root of x plus 8 equals the square root of 3x plus 8. Okay? I need to square both sides. So I'm going to square both sides. And what that does, it's going to get rid of my square root. So I'm left with an x plus 8 equals 3x plus 8. Now I'm going to solve for x. So I'm going to put my x's together and my numbers together. So I'm going to subtract an x to both sides. And I'm subtracting 8 to both sides. Leaving me with 8 minus 8 being 0 here. And 3x minus x is 2x. Well, I have 0 equals 2x. I'm going to divide by 2. And now I have, well, 0 divided by 2 is just 0. So 0 equals just an x. I can rewrite that to be x equals 0. Now be careful. A lot of students will see 0 divided by 2. Oh, they'll say like undefined. No. 0 is on top is fine. Divided by 2 is great, but it becomes 0. Be careful with that. And I rewrote it to have x come first because that looks nice and neat. So let's go check our work. So let's check it. So we have x plus 8 here. I'm rewriting my equation. The square root of x plus 8 equals the square root of 3x plus 8. Now be careful. Once you're comfortable with zeros, I love plugging zeros in. It really eliminates things quickly. So we have 0 in for x here. 0 plus 8 equals 3 times 0 plus 8. Excuse me. Well, 0 plus 8 is just 8. Square root of 8 here. And 3 times 0 is 0 plus, sorry, let's not skip a step, 0 plus 8 here. So 3 times 0 is 0, add an 8. 0 plus 8, we already knew was 8, so the square root of 8 equals the square root of 8. Left and right are equal, fantastic, showing me that we have no extraneous solutions and that x equals 0 is my final answer.
Minute Math. When you need help, you use Minute Math. Minute Math. Minute Math. When you need help, you use Minute Math. MinuteMathTutor.com.